Hemodialysis is a technique that replaces the main function of the kidney by passing the blood through a filter, functioning as an artificial kidney where it is cleaned, returning the patient free of impurities. Arterial blood is taken from the patient and eventually mixed with the heparin to prevent coagulation, passes through the pump blood, and next passes through the dialysis filter, and then return to the patient. Single patient hemodialysis system can be divided into three major components: the dialysis delivery system, the dialyzer, and extracorporeal system. This is the concentrate and mixture and conductivity control. The mixture of concentrate is made acid and bicarbonated, and the level of conductivity is controlled so that it is in the appropriate range. A solution of purified water with an electrolyte composition similar to that blood. Dialysis acts to remove metabolic waste from the blood and also acts as a source of ions to maintain the blood proper electrolytic and pH level, like you see in this marker. In this controller visualize the pH levels. With this range, the adequate conductivity and this part is the aeration and chamber flow, and water level are kept constant. It is section the water temperature is leveled at 35 centigrades to adapt into the patient temperature. The dialysis must have the characteristic of adequate conductivity and temperature that pass through this sensor, temperature and conductivity. Otherwise, it is discarded by the drain. Pass for this part. The dialysis pass through the dialyzer for solute and flow removal and return to the patient for this. The delivery system prepares dialysis and delivers it to the dialyzer. Then the external blood delivery system, extracorporeal blood circuit, circulates a portion of the patient blood through the dialyzer and returns into the patient. Usually, an arterial and vein in the patient's arm are surgical, joined for circulatory access. This junction is called an arterial venous AV fistula. In this button, we can listen step by step for daily, weekly, and every 6 months of maintenance. The simulation has to the blood leaking alarm and the blood detector error. These two alarms. At the moment that one activates the system, stop immediately. The system stopped because the alarm is activated. Each alarm has a button to listen to what may be the possible filter to activate and what to dissolve. This is an example that audio of the possible cause for that the alarm is activated. This button, the every way button, also contains information on possible faults and how to act. Also have a cleaning process and corrective maintenance. Here is how to maintain the containers. Here is how the maintenance and cleaning of the blood pump should be done. Here is how to change some parts and how often the preventive maintenance. And here is explaining that disinfectants are suitable for dialyzer cleaning.
Preventive maintenance. Replace O-rings, sterilizer and dialysis fluid, connectors, safety valves, filters, peristaltic pumps, segments, and calibrate the machine, pressure ports, valve body, connectors, sensor height and low level, and pH sensor with an operating jet. Hemodialisis machine user maintenance. Daily cleaning and disinfection. Rinse the machine with distilled white vinegar, acetic acid or citric acid 5% for a time between approximately 10 to 60 minutes. This is done to prevent debris from accumulating in the hydraulic system after treatment. Disinfect the hydraulic system with hot water at the temperature of approximately 18 centigrade. After each treatment, at the time of finishing the treatment for each patient, the external surface should be cleaned with a cloth and a disinfect cleaner, and the blood lines and transducer protector should be rattled and discarded. Audiovisual checks. If any leak is audible, check with soapy solution. Check all cells, connector, adapter, and parts are free. Check all moving parts move freely and fuel are unblocked. Weekly cleaning and disinfection. This is responsible for disinfecting the system by means of a chemical and is immediately rinsed with water to clean the extra waste. Cleaning and disinfection of the bicarbonated containers and the suction lid. Audiovisual check. Check connection for leak with soap solution and drain off. Check all fittings for proper assembly. Replace any deteriorated hoses and tubing. Every 6 months, cleaning and disinfection. General cleaning of the external part, external modules, and electronic. Technique maintenance. This must be made by a biomedical technician. Shining springs from bicarbonated and acid pumps. Change of coils of the degassing pumps. Ultrafiltration pumps, spring change. Arterial pressure, maximum and minimum limit. Possible cause. Simultaneous actuation of this error with dialysis or venous pressure related error. Folding or occlusion of blood line between venous drain chamber and patient, or occlusion of the line with rubber clamp. Thrombus formed at mesh of arterial drip chamber. Action. Remove thrombus or replace blood line with new one.
Blood pump rollers. Do not clean the rollers of the blood pump by immersing them in disinfection, since the safety device anti-return can be destroyed. The solution for external disinfection are Meliseptul 100%, Mercy 10%, Melcel Reserve 10%, Rixapar Plus 10%, Chlorobleach 0.8%. Dialyzer. Chemical disinfectants are used to disinfect the dialyzer such as formaldehyde or polysterol 340. Special rinse techniques should also be used to ensure that the disinfectant concentration is reduced and maintained at an appropriate level.
Venous pressure maximum and minimum limit. Possible cause: error occurrence during single needle dialysis. Thrombus formed at mesh of venous drip chamber or at shunt connector. Failure of venous pressure sensor board. Action. Set upper pressure change limit of SN correctly. Remove thrombus or replace blood. Short water supply. Possible cause: occlusion of water supply filter, folding or occlusion of water supply line, leak from water supply system, water supply stop. Action. Clean the filter or replace it with a new one. Repair leaked site. Operate water supply equipment. Correct the trouble.
Concentrate containers. The containers used for the bicarbonate concentrate should be disinfected once a week. Dilute chlorine 1 to 100 to be used for this purpose. After disinfection, rinse a bottom with treated water.
Air bubbles detected. Possible cause: accidental dislodgement of blood line for air bubble sensor. Malfunction due to external noise. Failure of air bubble sensor board. Action. Correct air introduction site and collect air in drip chamber. Return the leak alarm. Possible cause: excess leak from dialyzer. Action. Replace the dialyzer with new one.